Hello, Miss Smith. Okay. Kylie there.
Yeah,
We need you to take care of all the basics like the norms. What we got to do today. We're going to get right started. Get in and out. Are you logged into Edsby?
mm,
Cool. All right. So let me do this. All right. I need you to take care of the norms real quick. 20 points.
no one has the right to hurt another person's education or pass from safety. We will never behave in a way or discredit ourselves, our school, our family, or the class. Academic self-worth student always asks for the integrity. We take pride in self-academic self-worth. We respect the opinions of others. We respect the culture of the classroom. We are attentive to participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Awesome. Awesome. All right. So usually Rush would do it, but I'm going to have to do it. So GGI and Townhouse is, there's Davenport. 1 second. Welcome to class, sir. All right. Mark him present. Did it go? It went. Okay. As I was saying, I'm sorry. GGI Townhouse is daily. It's every day, and it's around 11:15 a.m. to about 11:45, I think. And they have great discussions. If you participate in those discussions, you get anywhere from 5 to 10 points. A few people participate in discussion, and usually, if I see a student, I try to tell another teacher like, "Hey, help them out with a few points." They really were engaged in that discussion. I think today was about the effects of gossiping. Like, should you care about it or should you pay attention to what you should be doing? That was the topic. And then there's other opportunities they try to, inform the staff, the students about. So it's 11:15 a.m. every day. And if you need the link, you can ask any of the teachers for the link to get there. All right. So try to participate with that. Another big thing that is going throughout the school, because I'm real big on computer literacy and just literacy, period. If you're an engineering student, which you all are in this period, you're going to need to know how to use a computer and even build one. For the physics students, they learn how to use it as a tool to measure the laws of nature. And in computer science, they learn how to utilize it for the need of being able to control automation. So that's the programming part or controlling the systems that the robots usually run off of. So if you need your kit, and you can schedule to come up to the school. I'm usually in the building on Thursdays and Fridays, and I'll even help you get your kit up and going. If your kit is damaged for some reason, just bring it up there with all the parts because I need those back, and I got to try to fix it so we don't run out of parts or replacements, and swap it out for a new kit. All right, so schedule with the school when they come up. We have to make sure we limit how many people are in the building. All right, so Mr. Davenport, can you read this? This is another initiative for points for everybody.
Wednesday and Thursday to code from the convenience of your home and get extra credit for some of your classes. The pandemic's effect on the coding job market. Why learn to code? The surprisingly broad benefits of coding. Interested? Join by clicking the link.
Thank you, sir. That's at 4 p.m. Wednesdays and Thursdays. So you guys use that link. You always come back to my classroom, that Bitmoji classroom that comes with your Edsby every day. You click on that and get back to this whole thing. Ms. Smith, can you read this here? It says daily, all the way down to daily.
Daily tasks, students will be able to complete the evaluation of ISB. Hello, our aspiring students, welcome to class. Inside of ISB, you can access all pre-recorded videos of each class. These videos are normally ready to review by 4 p.m. daily.
Awesome. That's awesome. All right. And then next, we're going to come here to CTE, stands for Career Technical Education. That's you trade school students or engineering students. So Davenport, you're up next. This is for 20 points. Can you read what's necessary?
Classroom term of the day is electric field. The word of the day is defile. Today's objective. Students will be able to analyze the connection between the electric field and the electric potential.
Very good. All right. So let's jump into today's assignment. I'm going to give you guys a link in a minute, but it's going to come via email. I'm trying to make sure you have a secure link. Some students, when I sent it to them as an open link, they were messing up the work. And the reason they have to not do that is because when we're doing quizzes, I want to be able to give you the information again in case you forgot. what to do. Because if you've seen my quiz last time, it was just a problem we did a long time ago. You just had to have good notes and you'd be successful. So we're back in that mode again. And all next week, we're going to be utilizing those Raspberry Pi kits that we discussed in the announcements earlier. So make sure you have it, because it's going to be going from the regular you do my notes to you got to program something to make it do something, because you're an engineer. You have to make it automate or work. And we're talking about the sense hats. We'll talk about that next week. But let's go into this. I'm probably going to take you through the book assignments first and then into the actual kit and what it does. Is this the robotics? It was the robotics, and I clicked on physics. Okay, so a couple of quick things you're going to need. Let's go here. Okay, electric potential. I wanted both classes to get a taste of FET simulations to see how fast they load it. So I'm going to grab this. And this is an explanation that is more aligned to what you're doing. I think in the other class, physics, it was just to introduce them to the simulation. But for your particular problem, it is aligned to what's going to happen in the problem. All right, so now what I want to do is I'm going to ask you to put your most recent email address in the chat. I think the chat is on or no? Let me see here. No, it's not. All right, so put your most current email address in the chat, and I will share this link to you right now to give you a head start on today's assignment. So let me make some adjustments. So you're going to have to put today's date here. And I'm just waiting for you all the guys to put it in there. I see Davenport's good. Waiting on you, Miss Smith. Name. And when you get in there, do not change my document, everybody. You're going to make your own copy. You're going to go to File and make a copy. Class. That's the class, and this is not the date. So you put that in, and you're going to have to put your name where my name is. I got everything else right except for this. This is not the right one. Okay, I got both of you. Good. All right. So the word of the day for the class, for the whole school, is the file. Let's give you a head start, and you got to put the definition in. And then what was it? Our other term was field, right? And don't forget, like the other one, to put the definition in. You got to look these words up in Google. If I were you, while you're waiting to get this link, I'd be looking at these words, so you can go ahead and put the definitions in there and get those easy points. All right, so let me come here. This is not correct. This is it's called what's the charge, right? Something to that nature. So leave that there. I'll fix in a moment. I want to get you guys into the actual document. Copy. Okay, and then we're going to throw you in the mix. Now you need to be in your email address account to even get the invitation to this document. So hurry up and log into your current email address, because it's about to come to you guys in one moment. And again, once you get in the document, do not change it. Make your own copy of it. All right, so here's your notes. It's going to power you through today's assignment. But do not do it. We have to do our simulation first. I'm going to show you how to do the simulation before we do the problem. Now, this problem is similar to the second problem, which you're going to be responsible of. But you're going to have to finish the calculation here, and it's going to be measured in newtons per coulomb. So you got to find that final answer. And you should be checking your email, because that's where it went, the link, to get into it. All right, now your notes, you don't have to worry about the notes. This is how it was solved from here to here. And some algebra was used in the strategy. So you have to make sure you have similar notes to me when you're doing the problem. So let's zoom in some so you can see it on my screen. But more importantly, you should be able to see it if you got into the document by checking your email. So if you're having a hard time seeing it on my screen, it's because you're not in the document yet. And I'm waiting to see who could pop in. So did y'all check your email addresses? Okay, I see Ms. Smith arrived. Okay. Waiting to see what's going on. Okay, Davenport. So right now, you two make a copy. Do not change anything. Go to File up here. I see somebody's got they're about to change. No, make your own copy. File, make a copy. Once you do that, then you make your changes. So don't forget, change my name to your name here. Don't forget to put the date in after you made a copy, right? Don't forget to put the date in. And then hurry up and put these definitions in so you can get those points. I did most of the work for you too. Next, you're going to need to click on this link here where it says simulation. So I'm going to highlight this because this is what I want you to do first. I want you to get your animation screenshotted into your document. So I hope you're following along with me, because right now, if I were you, I would not do any of that. I would just go ahead and click on the link because it takes a little bit to load. So I'm going to click on it and I'm going to show you what I mean. I'm going to click here. I want to go there. Let me do it this way. No. There we go. Now, how do I go straight to the link? I'm going to see. Can I just go to the link? Copy link, open link. There we go. And then it opens a tab. There we are. And you see, it takes a little bit to load. So you want to do this part first. I want you trying to do this at the very end and then you run out of time. So I want you to have time to share out and see if you can work on that problem alone. All right, so I'm letting it load. I'm letting it load. And you want to do this with me because depending upon your internet speed, for some people, it might be faster or slower. So do this part first. It's the link that I highlighted in the middle of the document. It says simulation link, I think, right? Okay, so mine is almost done. Davenport, did you have trouble opening this simulation up? Smith, what about you?
Mine loading.
You said yours is not loading or loading?
It's loading right now.
Oh, okay, good. You caught up. What about you, Miss Smith? Is it working for you?
It's still loading.
Okay. At least it's loading because it takes a bit, as you can see. That's why I said do this first. Do not tackle that problem yet. You have your notes, you have your own copy, but do this first. I'm gonna show you what you got to do. So I'm thinking once mine loads up, you're gonna do as I do on the screen. If you do it with me, you're gonna be like, what happened later or something. Okay, there we go. And it should say Capacitor Lab 2.02. And I want you to follow along with me. Once you get this screen here, you're going to click on multiple capacitors. Okay? Make sure you click on multiple capacitors. That's the section we're working on. If you don't do that, there'll be certain things that are missing from your settings that you need for your screenshot. Now what I want you to do is turn on all of your values. If you come to this right-hand side of the screen, you have view, meters. I'm going to tell you exactly what you got to do to get full credit. So what you need to do is first turn on electric field lines. That's in the view section. Next, all of the meters, including the device we're going to measure with. So these are graphs that show us total capacitance, stored energy, stored charge, and voltmeter, which is a tool that we use in real life to measure any type of electrical device to see how much voltage it has, right? Okay, so the last thing you're going to do, well, it's not the last, we're getting close to the thing, is we're going to put 3 in parallel. Okay, so 3 in parallel. That is going to be 3 capacitors. This is what your problem talks about with the plates when we go back to it. In parallel series circuit. So it's a series, it's a loop, but if there's branches in between, it's called parallel. So as you work through these problems, you'll start to understand this so you can do things in engineering, especially my old field, electrical engineering. All right, so we're going to do a setup. We got to first turn on the battery voltage. I hope you guys are following along with me. All the way up to 1.5 volts. All right, and because we turned on electric field lines, you'll see that there's electric field lines in between these plates. Remember, this is how it looked at 0 volts. There was like no field lines, right? So you see the difference. But if I increase the voltage all the way to 1.5 volts, the maximum amount, you see not only current was induced, those blue arrows, but also a certain amount of electric field for each capacitor. So here's what we're going to do. I'm going to change this one here, or no, leave this one here to like 0% and change a space of these plates. The capacitance for this one is how you change capacitance, the plates, right? I'm going to change this to 50%. That's right in the middle gauge, right? And then pay attention to these gauges. They're changing. Also, this one's going to go maximum. So that's 100% capacitance. So the plates, and you look at the numbers, they get kind of smaller, right? Okay, so now we're going to measure each one. The red lead is usually for hot, or the positive side of the plate. So you put that on top of that plate there, just touching. And the same thing for here. And now you notice it's 1.5 volts here. This is with the plates all the way apart, right? Now, if we do it here, we're going to take the negative side of this meter and put it there in that bottom plate and the positive side on the top plate. And this is, let's see if we can put it right on the plate. All right. Looks like it still says 1.5 volts, right? Let's do it to this one. Come over here. I'm going to put this here and take it off of there and put this here. What do we get? It's still 1.5 volts. So in physics, they saw series and it was like different measurements. But the main thing here is capacitors is they're going to keep the same voltage values on each branch, all right? No matter how much the capacitance changes. Now, your screenshot should be as I'm leaving it now. Remember, the last capacitor is at 100%. This capacitor is at 50%. And this is for separation of the plates, everybody. And this one here is at full plate expansion. But if you notice, when I did the measurements, it was 1.5, 1.5, and 1.5 volts across. So I need you to take a screenshot of this now and do as I do. To do a screenshot on a regular computer, you press the button called PRT screen. So you do that right now. If you've been doing it with me, you can have this part done. So I hit the print screen button on my keyboard. And if you don't know how to use screenshots on your computer, you need to look up the model of your computer and be like, how do I type in Google, how do I use print screen or a screenshot on my computer? You got to put the model in there. Okay, so once you figure that out, but if you have a keyboard like mine, you just hit that button once, which means it copied it, the entire screen, and then you're going to paste it into your Google Doc. So it looks something like this when I do that. Put it right here so you can see it. And I can just hold Control and press V for paste. It should pop that in there for me. There it goes. And then now I'm going to clean the document up. So you should see my screen now, right? I'm going to crop, which is C-R-O-P, image, this button here in Google. And I'm going to just cut out the information I don't want to include with my image and zoom in on the image. This is very essential to learn in case you guys need to do resumes and you got to cut out information that you don't want, them to see on your credit card or something. You just want to show them a statement. It's very good to know how to edit your information. All right, so now I got that. I can click outside the border and stretch it out a little bit. You got to play with this to get it right, so I want you all to do it now as opposed to later. It's 1:53. We get out of here at 2:30, so we're on time. Give you some time to do it yourself. And essentially, you should have this type of document. Now, I'm going to delete it because I don't want nobody cheating, right? Don't copy my document. You got to do it your own. So I want you to do what I just did. I'm going to leave the simulation up here in a moment, but let's cover the objective one more time. And don't forget, even though you get the simulation part done in 10 minutes, you're not done. Next, you need to use this strategy of mine to calculate the final answer for the first problem. And I did most of the steps. I showed you how to calculate. And then redo the same procedure to try to get the second problem completed. Okay? So think about this one here because now you got to use some algebra. All right, but I want you guys to get most of this stuff done. The simulation picture, your screenshot, and figure out the final answer here. And if you can, try to figure this out. And at the end of the timer, I'm going to give you some clues on how to go about it. It's going to require, I'm going to let you know in advance, it's going to require a little bit of algebra. It's not as easy as just redo. You have to actually do some algebra. Okay, so we do an objective. Let me blow this up for you. Okay, how about Miss Smith? I want you to try to read the screen. You there?
It's not up to.
Oh, why not? Oh, I see why. My bad. Let's do this. And that. How about now?
Passing time of the day is electric field. Word of the day, define. Today's objective, students will be able to analyze the connection between the electric field and the electric potential.
Awesome, awesome. Okay, so now what I'm going to do here is Don't forget to look up these two words, you guys. That's some of the points towards the document. That's in your exit slip portion. Is 25 points. Do that now too. But let me come out of this and show you what you're supposed to have done as far as a screenshot of that simulation. So I'm gonna leave this up with the clock, and you have to redo it on your own. I showed you everything you got to do. Take a screenshot, put it in your document, then work on that problem. Finish off by calculating the final answer. All right, and then try to figure out what the second question is. You have until 8 p.m. to finish all of it, but you should have most of it completed in 10 minutes. This is real easy to do, right? Gave you everything. Okay, I hope everybody got this image completed. It was the simulation. Simulation was given in a document, and that was the one you made a copy of. If you don't remember how to get to the simulation, you should have at least this part done and a screenshot of that image into your Google Doc. All right. Pretty much. The link is here for the simulation. You should try to get that completed by 8 if you don't have it done already. We're going to do share outs. And right after the share outs, and of course, after the norms and objective, we're going to cover the so a little bit of the second problem, but I want to make sure people know how to calculate because I saw Mr. Davenport had a question, but it's like I wanted him to try it out. You used Google last time, right? That was the way I showed you to do it, but I'll cover it again. I wanted you to try it because you're going to get used to. I don't have a calculator in front of me. You can use Google. Guys, search up all sorts of things. If you use the Google correctly, it can do a lot more. So you see the objective. Here we go. Present. Okay, and it keeps doing that. So I gotta do this. It's thinking, it's thinking. All right, good. And it'll do this. Okay, so let's think, Mr. Davenport, can you read that for points there? Mr. Davenport, are you with us or are you left? Okay, I guess he stepped away. Miss Smith, can you read what's there?
Fasting term of the day is electric field, word of the day to 5. Today's objective, students will be able to analyze the connection between the electric field and the electric potential.
Okay, it's 20 points. Now, I want to talk about how to calculate. Then we're going to do share outs. So let me come out of this. So it's real easy to calculate things in Google. All you need to do is put an equal sign, right? So what is the calculation for this part right here? Well, if we go to the robotics, and I told you to go through and calculate the final answer. The easiest way would have been to take in this part here with the equal sign, showed you this last time, and input it into a search for Google. Not in the search bar part, but in the URL. So if I copied this part here, and now I want to calculate that. That's why it's important to do the notes correctly. So you'll know what to put into Google and what not to. The measurements at the end need to be correct too, by the way. That lets me know if you understand how to cross things out correctly. So let's go through a little bit of it. We'll put that here. I'll just paste it into the URL. It's the address bar, right? And then I hit enter. All I did is put an equal sign before all that. And oh, it is scientific notation. Hold on. Okay, make the equal sign right after it. So that's probably the glitch. Let's try it again. Should calculate everything correctly. If not, I'll give you a search tool. Okay, waiting for it to go in. Okay, maybe it's because I'm logged in with this. Let's use this tool. Maybe that'll help you. What was it? I think it was Math Papa, because I think last time I used Symbol Lab. You guys can bookmark this in case it gives you trouble with Google. All right, this is better. So let's calculate. And then what I want to calculate, let's see if I can plug it in here. Okay, I'm gonna take the equal sign away. And let me put Math Papa in the chat so you guys can use that for the second problem as well. This might be an easier route for you. So give that a whirl. And if I hit calculate, you'll see it has everything correct. Is that correct? No, this is supposed to be squared, so it's not correct. So let's fix it. To be caret 2. I think that's right. Now what do you say? That's better. So that's the final answer. I'll type it in for you in case it gave you some trouble. But you can use this tool to calculate it. So the final answer would be, what does it say? It says 7,333 point, I think it was 15.
Mine didn't get that.
Meaning your Math Papa?
Yeah, mine didn't get that.
13. So you got to check and make sure you did it like me. Do you see my screen?
Yeah, I copied and pasted from the thing.
Yeah, but you got to change it, right? It has to be squared
How do
at
you
the
make it
bottom.
squared on the laptop?
Right, I just showed you, so pay attention again. So it's going to be a 2 there if you just copy paste. What you have to do is you have to hold shift and press 6
Okay.
and raise it to a power. You see that power sign pop up like mine's here?
Yeah.
You're going to put the 2 in there. So I deleted the 2 and I'll put it to the power of 2. Now hit
Okay.
enter. Huh?
I said, okay, thank you.
Did that? Okay, so I guess we fixed it for him. All right, so the answer is, so it's not 1 5, it's 1 3, because that 5 there is going to turn that 2 into a 3. So come here. So maybe I'll, now as a note to myself, I need to just let you guys use Math Papa and do calculations. Who gives you trouble? All right, so now you know how to put it in there. And even here, you can see where I got that square term for my notes. So be comfortable doing that. Now, look, it's 2:12. We only got a little time left. I want to see if anybody got this second problem. Did you all figure the second problem out? And did you get your simulation into your screenshot into the document yet? Don't forget that. So I'm going to go slowly through this because I'm not sure if you know how to do the algebra. Okay, so hope you're paying attention. Now let your potential, we got to start off with our known and unknown values, you guys. Grab this part and copy this section here. And you can follow on my notes. They're still there. You can always go back and refer to it. But if you scroll all the way down to problem 2, you'll see me working on it. So you might want to be copying what you need from me as I go through it. Now, what does this problem say? What do we actually have? Well, it looks like Q in this problem here, if you're looking at what I'm doing, is unknown. Because they say, what is the value of charge Q? So I'm going to remove this Q and put it over here. So I'm going to cut it out. And it looks like we have voltage. I see volts. So I'm going to bring this over here. And how many volts we got? We got 2.8, right? And what else I got? And if you can't see what I'm doing, you can always log back into that link I emailed you guys to catch up with these notes I'm giving you right now. And then to the fourth. That's the first known value. The next one is going to be, of course, unknown. And it's not going to be this because, again, this is a different problem. It's asking you for it. One quick question mark right there. What about R? Well, R is meters. So no, it's not 2.87. That's from the previous problem. It's 1.1 meters right there. K is a constant, so it doesn't change. Now, the only problem is the other problem we were solving for, I think, V, right? Yeah. So this time around, using this equation here, which is our strategy, and copy this, come down here, and we're going to say, what is the strategy, Mr. Tyler, right? So strategy here is to solve for the charge, right, which is Q. I hope everybody's getting these notes. I'm giving away how to do the homework problem. Are y'all with me, or y'all went and took get a sandwich or something? So I'm going through it for you.
Yeah.
Okay, I want y'all to be successful. Now, strategy is to solve for Q using algebra. So this is where you're going to have trouble if you don't remember your algebra skills. You need to practice that. And I think it's a 2 or 3 step situation. So the equation we're solving with is this one here. This is from your notes above. So follow with me. I got to get R by itself. And here's you do it. And I'm sorry, Q. And here's how you do it. So I'm going to copy this and I'm going to go through the steps with you. So please follow along. And put it here. This is me about to rearrange it. So to get Q by itself, I first got to get K on the other side. Now K is being multiplied. So I'm going to put brackets around this entire thing because I want to do something to it in a way that's going to remove K. So if K is being multiplied, the opposite in algebra for each operation is you're multiplying, then you need to divide to go reverse. If you're subtracting, you have to go add to go reverse. That's how it works. All right. So what you do to one side, you got to do to the other. Keep that in the forefront of your mind. So with that said, if it's being multiplied, that K there, because I want to break it off so I can get to the inner parentheses, I'm just going to divide by K. I hope you understand what I did there. But what you do to one side, this is what algebra says, and this is how you mess up sometimes if you don't stay consistent. Put brackets around the V. What you do to one side, you got to do to the other. How much time we got left? We got till 2:30, so I can do some more, right? I thought I was gonna say 2:20. We're good though. So now, if you're following along, you should be putting this in your document because I'm giving you some of the homework problem. We're gonna cross some things out. So grab this here, go right here. Now, again, what crosses out? Well, we know K here is gone. You highlight that, format. We're gonna strike that out. Now, some other stuff crosses out too, like this K in this bracket over here. That K divided by K, disappears. K divided by K is 1. So I'm gonna cross that out. And we have a new equation now. We gotta keep working because we don't have Q by itself. I'm literally doing the homework problem. I hope you're keeping up with me.
Don't you get a multiply?
Okay, that was not exactly. What is your new equation? What do we do in this situation? We want to get Q by itself.
Oh, you want to get Q by itself? You got to multiply R, I believe.
Not
Isn't that
multiply
division?
R. Not well. Q is being divided. So if you multiply by R what though? You're close. You say R. I'm trying to get you to say R what?
R squared.
There you go. You didn't say that. You said R, man. All right. So I'm not being petty, but I want you to know what's going on. Some Kyla coming in and grabbing the notes. All right. So hold on. I'm gonna put parentheses because it's being divided at R. We want to get it to the other side. R, and I'm gonna hold Shift. Well, I'm not gonna press Shift. I'm gonna raise it. 2. I gotta turn on.
Limblum, that was the first thing we were taught.
Said what? I'm sorry. What happened?
I'm sorry. I didn't know I was off mute. I was talking to my cousin about something.
Oh, okay. All right. I'm like, what happened? So we're gonna put R squared. So we gotta raise this to the power of 2, right? And you want to highlight the 2 there. And I'm going to format. I'm teaching you how to do these strikeouts and raisins because your notes had to be the same like mine's. And a lot of students keep saying, I don't know how to do that or whatever the case may be. So you got to take your time and do it just like me. So now it looks identical. But again, what you do to one side, you got to do to the other. So I'm going to copy this and come to the other side of the equal sign. And I'm going to put brackets around all this because I want to be able to make sure that it's multiplied correctly the same over here. Okay. So now some things will cross out. Well, let's see what it will cross out now. Well, we know R squared and R squared is going to go away. So it looks like pretty much Q is going to be by itself. R squared divided by R squared is 1. So I'm going to cross that out. And then I'm going to come over here and I'm going to cross this out. So now we have a new situation. I'm going to rewrite it the way it should be. So I'm going to grab this and we're going to rewrite it to clean it up because there's a new equation there. So I'm going to say, basically, because when you do math, you do from left to right when you do your mathematics. So all this is going to be equal to what? Well, Q, right? We were looking for. Not big Q, little q. Big Q. Okay. So now we know what Q is equal to. It is going to be on you guys now to cross out the right values and get Q by itself. And you do that by using some of the notes. So let me start you off. Now you plug in the values. So now plug in the values. Okay. We were reviewing this again a little tomorrow so we can see how close anybody gets it. Now plug the values into the new equation. Okay. A new equation is pretty much what we use algebra to find, Q. Copy this. Put this here. We're almost through, everybody. So what are some values? Well, let's go slow because remember, you got to put the correct information in. You can't just put numbers and you got to cross things out. And we got about 10 more minutes. So let me move a little faster because I'm going to give you 5 minutes in between your class. You only get 10 minutes. You a little time to stretch your legs. So what's the first thing we got to put in? Well, it looks like V, right?
V, yeah, you got to put in the one.
Right. I'm just making sure y'all with me. That's why I ask questions. So 5 points. The faster we get this done, then you guys be able to leave. I want you to have all your notes because you still have to cross out the correct things and get the final answer. So I'm going to replace this V with the value that we had in our unknowns, right? There's 2.8 times 10 to the 4th volts. What's the next value? What's K here? And yes, you got to put all that info in there. Because if you don't, certain things won't cross out correctly and you won't know how the equation is supposed to look when you calculate it. So this is our K value, or our constant. Try to put this in parentheses as a long value down in the bottom. Okay. And I didn't want that to happen. So I'm going to strike off. I hope you're keeping up with my notes so far. It's going to help you get this problem done quicker tonight. All this is going to be due with the correct answer by at least 8 p.m. tonight. So try to get most of it done in class so you don't have too much to worry about tonight. All right, so this is all in parentheses or brackets, right? Oh, that was supposed to be a parenthesis right there. Let me go backwards. And games with me. There we go. Parenthesis, yeah, the parenthesis went too big. I'm gonna turn that off. And there we go. That looks better. Last value is R, right? So what is R? Is up there, and it was 1.1 meters. So I'm gonna do this way because there's parentheses for it. 1.1 in meters. I'm getting that from the known values we established earlier, everybody. Now we're ready to go, looks like, right? So let me clean this up for you. And turn that off so you can just see what the equation looks like, right? We're at this point. Now I'm going to copy all this and cross some things out. It's going to be up to you guys to, again, figure out the final answer. So meters is up here, but it's meters squared because of this power of 2 here. So this is going to be meters squared down here. You can see what I'm doing. And then also you got this meter squared up here. So when they combine, they cross out. We're going to cross out that part. What else crosses out? Well, remember, you got Newton meters, which makes a force. And then volts has Newton meters inside of it because of its creation. So that's going to cross out with the Newton meters portion, or the Newton Coulomb portion. Just leave a Coulomb. So we can cross out volts. Okay. And then we can cross out these coulombs. This Newton right here. And we'll have just coulombs, but not Coulomb squared. So all that is going to be crossed out. It's going to be just a Coulomb. So I'm going to show you how to make that look correctly if you're following my notes. And this 2 here is going to, for this Coulomb over here, is going to drop down to just a Coulomb, therefore leaving only coulombs. So it strikes out. And then when we rewrite this, we have what? Whew, I did it in a minute. I made record time. I'm good. So when we rewrite this, remember out here you just have coulombs. What you see there is not crossed out. So I can pretty much remove what? I can remove this part. Meters is gone. That's what I didn't cross up here so you can see it. Almost. Okay. And then when we got coulombs over here, remember, put it into your math popper correctly. You should have, so this coulomb's going to be gone. Should have pretty much everything I gave you. Okay, looking good. And this volts is gone. The video will be available later on today, like around 4. And what's on the outside of this is just coulombs. You're going to have to calculate the final answer. And don't forget the simulation has to be there. The exit slip has to be done. But what is this final answer going to be in terms of coulombs? You got to look at the above part to get that answer. Okay. Highlight that. And it's pretty much at the end of class. Anybody got questions? You know what you got to do, right? Remember to get these notes from this and put it in yours, and then figure out the final answer is. All this is due as a PDF at 8 p.m. tonight. You click on download and then PDF, and you send that to me. Okay. You get a little bit of in-class points. But we're about to get out of here, so let's review the objective one more time. Everybody got the Math Papa link? You're going to need that to do the final answer for this section. And then the link for the simulation is already there in the document. So you're going to click on that and make a screenshot of this part here. So let me see, Ms. Smith, can you finish us off with the objective once more? If it lets me go to this slide.
Is electric field, what did they define? Today's objective is to be able to analyze the connection between the electric field and the electric potential.
Okay, you did it. Great. Okay. So I don't have anything else for you guys, and gals, I think that's pretty much all. You know which part to turn it in on Edsby. You go to that assignment today, and that was, of course, asking about what's the charge. I think we changed the name and everything. Devontae said, I don't need anything. He's gone. I was going to ask, he had questions, but you're pretty much through, Miss Smith. You know what to do, right?
Yeah.
All right. Well, see you in class tomorrow. Get it turned in before 8.